Kazakhstan. Summer 1976. The desert stretches endlessly in every direction, a landscape of dust and emptiness, broken only by scrubgrass and the occasional wind-carved rock. The sun sets blood red over the steppe, painting the horizon in shades of copper and flame. And then, rising from the flatness like something from another world, the domes appear. 3 massive structures, white concrete reflecting the dying light. Smooth, symmetrical, alien against the ancient landscape. Around them, a perimeter of fences and watchtowers. Soldiers who never speak to outsiders. Technicians who arrive on unmarked trains and disappear into underground corridors that spider out beneath the visible structures. This is Sari Shagan. The official designation is innocuous. Soviet Missile Defense Test Range, but the Americans tracking it from orbit know better. The infrared signatures, the power consumption that rivals a small city, the careful way Soviet officials never mention what happens inside those domes. Inside, tonight, something is about to happen. Technicians move through corridors lit by emergency red lighting. They check instruments, calibrate mirrors the size of dinner tables, verify alignments measured in fractions of a degree. The hum of generators builds beneath their feet. Power surges through cables as thick as a man's arm. In the main control room, a colonel watches screens filled with data that would mean nothing to most people, but he understands. He knows what this facility was built to do, what it represents, what the Americans would give anything to understand. He gives the order. Switches engage. The hum becomes a roar that vibrates through concrete and steel, and somewhere in the depths of the complex, in a chamber lined with exotic optics and cooled by liquid nitrogen, something awakens. Light, coherent, focused, impossibly bright. Not the soft glow of a bulb, or even the harsh glare of a spotlight. Something different. Something concentrated down to a beam so tight, so pure, that it cuts through the air like a blade through water. The beam traces invisible patterns across the night sky, targeting, tracking, calculating trajectories that exist only in theory and classified documents. For a few minutes the facility operates at a fraction of its design capacity, testing systems, verifying concepts, proving that what the physicists promised could be built. Then it shuts down. The roar subsides. The lights dim. The technicians make notes in journals that will never leave the facility. The colonel files his report in triplicate, each copy stamped with classifications that mean death if violated. 8,000 miles away, in a darkened room at the National Reconnaissance Office in Virginia, analysts examine satellite photographs taken 12 hours earlier. They measure heat blooms, track power consumption, calculate energy outputs from the shadows cast by cooling towers, and they realise something that makes their hands shake as they reach for secure phones, something that will change the entire trajectory of the Cold War. What the Americans saw that night convinced them the Soviets had found a way to weaponize light itself. The year is 1972. The Vietnam War is winding toward its bitter conclusion. Détente is the new watchword between Washington and Moscow. Treaties are signed, summits held. Both sides speak carefully about arms control and peaceful coexistence. But beneath the diplomatic niceties, the arms race continues. Just evolved, mutated into new forms that most people cannot even imagine. The age of the missile is giving way to something stranger. Both superpowers chase weapons that move faster than any rocket, energy directed across vast distances. Radiation focused like a lens focuses light. particle beams that could destroy targets in milliseconds. The physics is theoretical, but tantalizingly possible. Lasers, discovered barely a decade earlier, show that light can be tamed, concentrated, made to do work. If you could make the beam powerful enough, focus it precisely enough, keep it stable long enough, you could burn through metal, disable electronics, destroy missiles in flight. This is the new frontier of warfare. Not bombs that fall from planes, but rays that move at the speed of light. Not warheads you can see coming, but invisible beams that strike before you know they are aimed at you. The Americans pour money into research. Lawrence Livermore National Laboratory, Los Alamos. DARPA programs with code names like Seaside and Triad. Physicists who once built atomic bombs now turn their attention to harnessing light itself. But they are not alone. The Soviets, always secretive, always ambitious, are pursuing the same dream. And they have advantages. Less oversight, fewer ethics committees, a willingness to build massive facilities in remote locations where failures can be hidden and successes exaggerated. The paranoia that defines the Cold War reaches new heights. Because how do you verify a laser program? You cannot count beams like you count missiles. You cannot photograph light like you photograph bombers. The invisible weapons are, by their nature, invisible. Rumours become as dangerous as facts. Intelligence reports mix speculation with observation. Both sides imagine what the other might be building, and those imaginations become blueprints for real programs. The fear of what might exist drives the creation of what does exist. And somewhere in Kazakhstan, in a facility so secret that most Soviet officials do not know its true purpose, a project takes shape that will become the embodiment of this new phase of the arms race. They call it Terror 3. Seri Shagan is not new. The site has been used for Soviet missile defense research since the 1950s. Vast, remote, protected by desert and distance, the perfect place for secrets. But in the early 1970s, something changes. Construction crews arrive. New buildings rise. Not the utilitarian concrete blocks, typical of Soviets. Military installations, but something different. Sophisticated, purpose-built for something specific. The 3 domes become the focus of American intelligence attention. Satellite imagery shows their construction in stages. First the foundations, massive and reinforced, then the walls, smooth concrete several feet thick. Finally the domes themselves, geodesic structures covered in reflective white paint. Inside each dome, analysts can sometimes glimpse equipment during construction, massive optical systems, mirror assemblies that suggest precision measurement, power systems far beyond what a simple tracking station would need. The Soviets offer explanations when pressed. Missile tracking, they say, satellite observation, radar calibration, all defensive, all peaceful. Nothing to concern the Americans, but the math does not work. The power requirements are too high, the optical systems too sophisticated, and there are details, cooling systems, shielding, the specific frequencies of light observed during tests that suggest something else entirely. The Americans compile reports. Codename, Pawn Shop. Every satellite pass over Sari Shagan is analysed. Every intercepted communication studied. Every defector questioned about rumours they might have heard. A picture emerges. Fragmentary, uncertain, but consistent. The Soviets are building a laser weapon. Not a small laboratory prototype, but something operational. Something that could, in theory, reach into space and destroy satellites, or blind sensors. Or, in the nightmare scenario that keeps Pentagon planners awake at night, shoot down missiles during their boost phase. Terra 3, they conclude, is not a tracking station. It is the prototype for a new kind of war. A war fought with light. Inside the Pentagon, in offices where maps still show the world divided into red and blue, physicists gather to assess the threat. They bring their calculations and their doubts. They bring their expertise and their fears. The question is simple. The answer is not. Can the Soviets actually build a laser powerful enough to be a weapon? The physics is challenging, but possible. A laser is light amplified and focused. Get enough power. Achieve the right wavelength. Maintain coherence across distance. Compensate for atmospheric distortion. And yes, you could deliver enough energy to a target to damage it, but the engineering is brutal. Lasers generate heat, enormous heat. The more powerful the beam, the more heat you must dissipate. And you need precision targeting systems that can track a missile moving thousands of miles per hour. Keep a beam locked on a target no bigger than a bus. Hold that lock long enough to burn through metal and circuits. The American scientists run the numbers. They build their own prototypes. They test and fail and test again. Progress is slow, promising but slow, which makes the intelligence from Sari Shagan so disturbing. Because if the reports are accurate, the Soviets are ahead. Not by a little, by years. They have built something the Americans are still trying to prove is possible. Meetings multiply. The CIA briefs Congress behind closed doors. Defense contractors submit proposals for countermeasures. Research budgets swell. The race is on, driven by the fear that the enemy has achieved a breakthrough that changes everything. And always the questions multiply. What if Terra 3 is more advanced than we think? What if there are other facilities we have not found? What if the next war starts not with missiles, but with beams we cannot see until it is too late? The paranoia feeds on itself. Every Soviet success, real or imagined, demands an American response. Every American program, real or theoretical, demands Soviet countermeasures. The spiral continues, both sides building weapons to fight weapons that may not even exist. This is the nature of the invisible arms race, where the threat is measured not in warheads. You can count, but in capabilities you can only imagine. Then comes October 1984, a moment that transforms speculation into crisis. The Space Shuttle Challenger is on orbit. Mission STS-41G, a routine flight by the standards of the shuttle program. Scientific experiments, satellite deployment, Earth observation. The crew is relaxed, experienced, moving through their checklist with practiced efficiency. The shuttle passes over Soviet territory. This happens on many missions. The orbital mechanics dictate it. The Soviets know the schedule. They track every pass. Usually it is routine. Usually nothing happens. But this time something does. Instruments on the shuttle register unusual readings. Brief, fleeting. Sensors designed to monitor radiation and electromagnetic fields show a spike. Not dramatic, not dangerous, but there, undeniable, lasting only seconds before returning to normal. The crew notices but does not immediately report it. Sensors glitch sometimes. Space is full of radiation. It could be anything. They make a note. Move on with their mission. Return to Earth a week later. It is only during the debriefing that someone connects the timing. The sensor anomaly occurred precisely as Challenger passed over Sari Shagan, over Terra 3. The implications spread through the intelligence community like fire through dry grass. The Soviets targeted an American spacecraft. They fired something at it, not powerful enough to damage, but powerful enough to be detected. A warning, a demonstration, a message. Or was it? The evidence is ambiguous. The sensor readings could have other explanations. Cosmic rays, equipment malfunction, coincidence. There is no proof, no smoking gun, no confession from Moscow. But in the context of everything else, the facility, the intelligence reports, the physics that says it is possible, the conclusion seems inevitable. Terra 3 is operational, and it can reach orbit. The story leaks, not immediately, but eventually. Aviation Week reports it, carefully hedged with uncertainty. Other publications follow. Soviet laser facility targets shuttle. The headlines scream. Space weapons threat, they warn. Congress holds hearings. Scientists testify. Some say the threat is real and urgent. Others urge caution, pointing out the lack of hard evidence. The debate rages in classified briefings and public forums. The Soviets say nothing official, but in academic journals and technical conferences, Soviet scientists begin publishing papers on high-energy lasers, atmospheric compensation techniques, tracking algorithms, just theoretical work, they insist, just science. The message is clear, even if unstated. We can do this. We may have done this, and you should take us seriously. In Washington, the response is swift and massive. Funding floods into directed energy weapons programs. New facilities are built, new contractors hired. The Strategic Defense Initiative, already proposed by President Reagan, gains new urgency and resources. If the Soviets have laser weapons, America must have them too, and better, and more of them. The invisible arms race accelerates into the unknown. But what was Terra 3 really? To understand that, you have to step inside the Soviet scientific establishment, into the world of brilliant minds working under impossible constraints. The facility is designed by some of the Soviet Union's most talented physicists, men who dreamed, as scientists everywhere dream, of pushing boundaries, of achieving what seemed impossible, of being first to cross a frontier. They understand lasers, they understand optics and precision, and the marriage of theory to engineering. They proposed Terra 3 not as a weapon, but as an experiment, a proof of concept. Can we build a laser powerful enough to track a satellite? Can we maintain beam coherence across hundreds of kilometers? Can we compensate for atmospheric turbulence? The military sees other possibilities, so the project gets funding, massive funding by Soviet standards. The facility rises in the desert. The scientists relocate, moving their families to closed cities nearby, places that do not appear on maps, where everyone works for the military-industrial complex, and everyone knows not to ask too many questions. The work is exhausting. Lasers are finicky. Optics must be perfect. Any flaw, any speck of dust, any misalignment measured in microns will scatter the beam, waste energy, prevent the system from achieving its potential. The targeting systems must be exquisite, the power systems reliable, and always there is pressure. The Americans are working on their own systems, Soviet intelligence reports. You must work faster, achieve more, prove the investment was justified. The scientists do their best. They solve problems with ingenuity and improvisation. Soviet manufacturing cannot produce some components to the required tolerances, so they hand polish optics. Western electronics are superior but embargoed, so they design alternatives that are bulkier but functional. Slowly, Painfully, Terra 3 takes shape. The laser itself is a carbon dioxide laser of proven technology, reliable, capable of high power. Not the most efficient design possible, but one they can build with available resources. The optics are magnificent, a telescope in reverse, taking the laser beam and focusing it to remain tight across vast distances. The targeting system uses radar and optical tracking, computers that fill entire rooms, calculating trajectories and compensating for the Earth's rotation. By 1976, they achieve first light. The laser fires. The beam reaches into the sky. The scientists celebrate quietly, knowing their achievement will never be publicised, never be acknowledged outside classified military briefings. But they also know the limitations. Terra 3 is not a weapon. Not really. The beam is powerful enough to dazzle optical sensors, perhaps, to temporarily blind satellites, but destroying something, burning through metal, that would require power levels they cannot achieve. Not with this design, not with Soviet technology in the 1970s. They report this honestly. The facility works as designed. It proves the concept, but weaponization would require improvements they cannot yet deliver. Larger lasers, better power systems, adaptive optics that do not yet exist. The military hears what it wants to hear. The facility works. It can target satellites. Good enough. Let the Americans discover it. Let them worry. Let them waste resources, countering a threat that is more potential than actual. And that is exactly what happens. Because in the calculus of the Cold War, perception matters more than reality. The idea of a weapon is often more powerful than the weapon itself. The Americans see Terra 3 and imagine the worst. Not a research facility, but the first of many. Not a prototype, but a deployed system. Not a laser that can barely reach orbit, but a network that could shoot down entire missile fleets. Every satellite pass over Serishagan brings new analysis. Every technical paper published by Soviet scientists is studied for clues. Every defector is questioned about rumours they might have heard third hand from someone who knew someone who worked there. The intelligence community builds a picture from fragments. Some true, some exaggerated, some completely invented by analysts trying to fill gaps in knowledge with educated guesses that gradually become accepted as fact. Terra 3 becomes a symbol, a focal point for fears about Soviet technological advancement. If they can build this, what else can they build? What other secret facilities exist in the vastness of the Soviet Union, hidden in deserts or mountains or tundra, working on weapons that will not be revealed until they are used? The response is predictable and massive. America builds its own directed energy weapons programs. The Navy develops lasers for ship defense. The Air Force works on airborne laser systems. The Army experiments with battlefield lasers that can shoot down rockets and drones. And in orbit, in the vacuum of space where lasers do not have to fight atmospheric distortion, both sides deploy satellites with capabilities that remain classified decades later. Optical sensors, targeting systems, and yes, probably lasers, though neither side ever confirms it officially. The Strategic Defense Initiative, Reagan's vision of a shield against Soviet missiles, becomes the ultimate expression of this arms race. Satellites with lasers and particle beams and kinetic weapons. A network that could, in theory, shoot down hundreds of warheads during their boost phase, their mid-course, their re-entry. Critics call it Star Wars. Point out the technological challenges, the cost, the strategic instability of even attempting such a system. But supporters point to Terror 3. The Soviets are already working on this, they argue. We must respond. We must match them. We must exceed them. Billions of dollars flow into research. Prototypes are built. Some work, some fail spectacularly. Progress is made, but the ultimate goal, a comprehensive missile defense system using directed energy weapons, remains elusive. The Soviets watch this with a mixture of satisfaction and alarm. Satisfaction that their facility has prompted such a massive response. Alarm at how much the Americans are investing, at how quickly they are advancing, and so they increase their own efforts. More funding for Terror 3, proposals for Terror 4, Terror 5. Research into free electron lasers, Excimer lasers, chemical lasers, each side pushing the other, each side convinced the other is ahead. The race consumes resources that might have gone elsewhere. Technology advances, but at tremendous cost, and all because of a facility in Kazakhstan that was never quite what the Americans feared it was. The truth about Terror 3 emerges slowly, over decades, as the Cold War ends and secrets gradually become history. Soviet scientists, free to speak more openly after the Soviet Union's collapse, give interviews. They confirm that Terror 3 existed, that it could indeed project a laser beam into space, that it was used in tracking experiments, and yes, possibly to test its effect on satellites passing overhead. But they also reveal the limitations. The beam power was relatively low, perhaps 1 megawatt at its peak, concentrated down to a spot the size of a dinner plate. Enough to dazzle sensors, perhaps cause temporary malfunctions in unshielded electronics, but nowhere near enough to destroy a satellite outright, let alone shoot down missiles. The incident with Challenger, they say, was real but exaggerated. Terror 3 did track the shuttle, may have illuminated it briefly with a low-power beam, just to test whether they could maintain lock on a fast-moving target. But the intent was not to damage, merely to demonstrate capability. American intelligence analysts, who spent years studying Terror 3, gradually adjust their assessments. Some feel vindicated. The facility was real. It was a directed energy weapon. The Soviets did target American spacecraft. Others feel foolish they spent billions countering a threat that was never as severe as feared. But was it a waste? That question has no simple answer. Because Terror 3, for all its limitations, did push forward the science of directed energy weapons. Both Soviet and American programs learned valuable lessons. Technologies developed for laser weapons found other uses: precision manufacturing, adaptive optics, atmospheric compensation techniques that now help astronomers see more clearly. More importantly, the response to Terror 3 changed strategic thinking. It pushed both sides to consider space as a battlefield, to develop capabilities and doctrines for fighting in orbit, to grapple with questions about weapons that move at light speed and cannot be dodged or intercepted by conventional means. The modern world's militaries now use directed energy weapons routinely. Naval vessels mount lasers to shoot down drones and small boats. Ground forces use them for counter-drone operations. The technology that was experimental and terrifying in the 1970s is now operational and mundane, and work continues on more powerful systems. Lasers that can disable missiles, particle beams that can reach targets in space, microwave weapons that can fry electronics from a distance. All the nightmare weapons imagined during the Cold War are becoming real, refined, ready for deployment. Terror 3 was the prototype, the proof that it could be done, the ghost that haunted the imagination of a generation of defence planners and drove them to turn science fiction into science fact. The irony is inescapable. Both sides raced to counter a weapon that barely existed, spent vast sums developing capabilities to match capabilities the other side could not quite achieve. The arms race became self-perpetuating, driven not by what was real, but by what might be real, what could be real, what the enemy might be trying to make real. This is the paradox of the invisible arms race. When weapons are secrets, when capabilities are hidden, imagination fills the gaps. And imagination, fed by paranoia and political pressure, always assumes the worst. The Soviets built Terra 3 partly because they feared American-directed energy programs. The Americans accelerated their programs because they feared Terra 3. Each side responded to shadows. Each side created the very threats they most feared by assuming they already existed. It is a dynamic older than the Cold War, older than nuclear weapons, older than firearms. Every advance in military technology prompts a counter-advance. Every shield inspires a better sword. The arms race is eternal because fear is eternal, and power always seeks to match power. But with directed energy weapons, with technologies that operate at light speed and can strike without warning, the stakes become uniquely terrifying. There is no warning time, no chance to detect a launch and respond. The battle happens faster than human reflexes can process. This is what Terra 3 represented to the Cold War strategists. Not just a weapon, but a fundamental change in the nature of warfare. The compression of conflict into instants measured in nanoseconds. The elimination of warning time that had always been the foundation of strategic stability. If both sides had laser weapons in orbit, if both could destroy the other's satellites or missiles within seconds of deciding to do so, how do you maintain deterrence? How do you prevent accidents or miscalculations? How do you build fail-safes into systems that operate faster than humans can think? These questions never got fully answered during the Cold War. They do not have good answers now. But they were asked seriously, urgently, because of a facility in Kazakhstan that may have pointed a laser at an American space shuttle one October night in 1984. Terra 3 is silent now. The Soviet Union collapsed. The facility was deactivated, though some reports suggest it was briefly used for civilian satellite tracking before falling into disrepair. The scientists who built it are mostly gone, their work preserved in classified archives and fading memories. But the legacy persists. In the laboratories where directed energy weapons are still refined, in the strategic doctrines that assume space is a battlefield, in the budgets that allocate billions for capabilities that seemed impossible 50 years ago. Sari Shagan still exists. The domes still stand, though weathered now. The desert has reclaimed some of the facility, but you can still see the concrete, the infrastructure, the bones of something that once terrified the most powerful nation on earth. What lessons does Terra 3 teach? Perhaps that fear is the most powerful weapon of all. That in a world of secrets and shadows, perception shapes reality more than reality shapes perception. That the arms race is driven as much by imagination as by actual threats. Or perhaps the lesson is simpler and darker. That once humanity learns to weaponize a new form of energy, we cannot unlearn it, cannot step back from the precipice. We can only race forward, hoping that deterrence holds, that reason prevails, that the weapons we build remain unused. Terra 3 was supposed to be defensive. That is what the Soviet scientists believed. a way to track missiles, to provide warning, to level the playing field against American advantages in other areas. A shield, not a sword, but there is no such thing as a purely defensive weapon in the arms race. Every defence inspires new offences. Every shield demands a better spear. The line between protecting and threatening blurs until it disappears entirely. The directed energy weapons of today are descendants of Terra 3, more refined, more powerful, more reliable. Some are truly defensive systems, designed to shoot down incoming threats. Others are more ambiguous, capable of attacking as easily as defending. And the race continues. Hypersonic missiles that move too fast for conventional defences. Lasers powerful enough to counter them. Particle beams that can reach deeper into space. Railguns that fire projectiles at velocities that make them essentially unstoppable. Each advancement inspires counter-advancements. Each capability demands counter-capability. The spiral continues, driven by the same fears and ambitions that built Terra 3 half a century ago. We live in the world Terra 3 helped create, a world where light can be a weapon, where the speed of conflict is measured at the speed of light, where space is not a sanctuary but a battlefield, where the future of warfare is being written in laboratories and test ranges most people will never see. The Cold War is over. The Soviet Union is history. The ideological struggle that defined the 20th century has ended. But the technological competition continues, sometimes between the same players, sometimes with new participants. China develops anti-satellite weapons. India tests laser systems. Private companies build capabilities that were once the exclusive domain of superpowers. The technology spreads, becomes more accessible, harder to control. And somewhere, in laboratories whose locations are classified, scientists are working on the next generation of directed energy weapons. More powerful than Terra 3 by orders of magnitude, capable of not just dazzling sensors, but destroying satellites outright, of shooting down missiles in their boost phase, of targeting aircraft, of changing the fundamental equations of military power. They are working, in other words, on making the nightmares of the Cold War into the realities of the present, on turning the weapon that Terra 3 hinted at into something fully realised and operational. This is the legacy of the facility in Kazakhstan. Not just the technology itself, but the demonstration that it was possible. That light could be weaponized. That distance could be collapsed to nothing. That the speed of light weapon was not science fiction, but science fact waiting to be perfected. The domes at Serishagan stand empty now, monuments to an era of fear and competition, but the ideas they housed are alive and multiplying. The more research continues, the race goes on. In the war for the future, even light can cast a long shadow. If you are drawn to these stories where technology and paranoia intersect, where secret weapons reshape the world, where the race for ultimate power drives humanity toward extraordinary and terrifying achievements, then join us as we explore more hidden chapters of the Cold War. Subscribe to uncover the classified programs, the secret facilities, the weapons that changed history from the shadows. Because the Cold War may be history, but its secrets are still being revealed. The invisible weapons, the facilities that officially never existed, the technologies that seemed impossible until they were built. And there are so many more stories waiting in the archives.